Serverless. You know my name by now, so I don't have to do that again. I created a company called Null, and what I want to do, what I try to do every day is to make things simpler. And along the way, I discovered serverless. And this talk is about sharing that experience and what I learned about serverless and how we can make our lives as developers simpler. So who has heard about serverless before? Please raise your hand. Okay, quite a lot. That's great. Who has deployed serverless applications? Okay, maybe I can teach you something then. What is serverless? Serverless is a big change. I mean, it's a change. Maybe it's not so big. It's a change in how we create and how we run our applications online. And it's a change because today, when we create applications, we think with resources. Resources like servers, like disk storage, like a CPU, RAM, and stuff like this. Going serverless is moving from thinking with those resources to going to thinking with services. So I'm going to give you some examples so that you can get your head around it. The most obvious one to me is storage as a service. Amazon S3 is a perfect example of something that is serverless. And it's not about code, but it's still serverless. We don't think about the servers behind Amazon S3, we just use it. But you can find many services today. It's like the era of the services. We have database as a service, which is getting quite popular, more and more popular at least. Caching as a service, authentication as a service, search as a service. You have so many services. And the idea with the serverless approach and all those services that you manage less stuff. You don't deal with the web servers. Yes, there are servers, but you don't manage them. You can scale more easily because this is the responsibility of the hosting provider to scale for you. Let's take the Amazon S3 example again. With Amazon S3, I don't manage the disk space. I don't have to check if it's getting full. Instead of paying and buying a disk of 200 gigabytes, I just use Amazon S3 and push as many files as I want. I can scale to very high volumes without having to monitor it or think about it. And then it's Amazon's job to scale the storage, and they are pretty good at it. And finally, and that's not always the case, but most of the time it's pay per use. You pay for what you actually use. Again, Amazon S3 is a good example because you only pay for the storage that you actually use. So that's great, all those services, but there is one service in particular that is pretty interesting to us developers, and that is function as a service. Function as a service is basically a service where we send the code to Amazon, Google, Microsoft, and they run it. That's their job. So what does it mean? Why is it called function as a service as well? These are two very basic examples of functions that you can deploy and run on Amazon Lambda. Amazon Lambda is the function as a service of Amazon. You have Microsoft Azure functions, you have Google Cloud functions, you have plenty of cloud providers. But this is just one example. The idea is always the same. You write a piece of code, and it's a function which takes an event and returns a response. In the JavaScript example, you can use a callback to return the response because this is asynchronous, this is JavaScript, but the idea is the same. You take an event and you return a response. Okay, great. Let's dig a little bit further. And let's talk about web applications, APIs, HTTP, because that's what we most commonly do with PHP. Where is HTTP in all of this? So what is a web application? After all, it's something that when a request comes in, it's a piece of code that runs. This is the blue bar. This is the piece of code. The green arrow is the web request. And when there's the request, something runs and returns a response, right? This is an event, and this is the function. But in reality, it's not really like this. It's more like this. You have the large blue bar, which is the web server. It sits there running all the time, and it waits for the requests. That's how it runs today. It's like Nginx, PHP, FPM, Apache, whatever you want. And when the request comes in, you have a bit of PHP code or any kind of code that gets executed. So moving from traditional hosting to serverless and to function as a service is actually moving from that to that. You don't deal with the web server anymore. You don't write anything that is long running, pulling something, waiting for something. You don't write any daemons or whatever. You just write the function that gets executed when there's an event. And the word event is important. It's not a random word. It could be an HTTP request, but it can as well be any kind of event, like there's a new job in the job queue to process. Again, you don't write the worker, you just write the function that processes the job message. It could be a cron. A cron is an event, like every day at midnight, run that command. It can be, hey, there's a new file on Amazon S3, you need to process it. That's an event. So the idea with the serverless architectures is like it's event-oriented. And for a long time, I wasn't really comfortable with the idea of event-oriented architecture. It seems quite new and quite different, but it's not. That's what we've been doing all along. It's just that instead of maintaining all that, these things that is always the same and it's not really useful to us, we write only our code and that's it. So what really happens? What actually happens here on Amazon Lambda, and that's the same for most providers, when there's an HTTP request, when there's an event, your code will actually be booted inside some sort of container. It's not a Docker container, it's what they call micro VM. It's a very specific kind of container which is optimized for the use case. Anyway, it could be a Docker container, who cares? Your code gets instantiated in an isolated environment, just for your code. And the code executes, processes the event or the request, returns the response, and then the container can die. It can be garbage collected, it can shut off, it can continue running, you don't care about it. When there is no request, there is nothing executing. Your code is not running. What happens though if there are 1,000 requests at the same time? Same exact millisecond. This happens. Your code will get instantiated 1,000 times in parallel, in 1,000 containers. And every execution is completely isolated from the rest. Which means that your code will only handle exactly one request or one event at a time, which makes it actually really easy to scale. Because since everything is completely isolated from the rest, you can have 1 or 1,000, it doesn't matter. The only limit is the number of servers at Amazon, and that's quite a good limit to have. Obviously, if everything here queries the same database, you will have some problems. So obviously what you want to do, if you write a serverless application and you expect very high traffic, you try to make it serverless end to end. So you try to use services that can scale at the rate that you want. And we'll get back to performances. Another way to understand how it works and when it will instantiate new containers, or that's what they call instances, is like this. So at first, here, there is nothing running. Your code is not running. But then there's one request that comes in. So your code will get instantiated in a container and run. And then that's it. The container will not immediately shut down. It will stay alive for something like 40, 50 minutes, it depends, but it stays alive to handle the next request quickly. It's just an optimization problem. So the next request comes in and it will be handled by the same container. But here a new request comes in and this container is busy. Again, one container, one instance handles exactly one request at a time. There is no concurrency. It's really easy to understand as an execution model. So it will instead create a new instance, and we have the same problem here. After some time, the container is not used for 40 minutes or 50 minutes, then it gets destroyed. That's how Amazon Lambda can scale very easily, because it scales at a very granular level. It scales up very easily, and it scales down very easily too, and very quickly. Now, what's really interesting as well in this execution model, so let's back up just a minute. We are PHP developers, and that doesn't seem, that doesn't seem really strange to us, because one PHP process handles one request at a time. But imagine if you're a Java or a Go or a Node or a Python developer. This is completely new. Basically, they reinvented PHP FPM, PHP CGI, but for all the languages. So if you are a Java or Go or Python developer, that's a really big change in architecture. You have to change your applications, you have to learn new patterns and new frameworks. But for us, this is really familiar. And our frameworks are compatible with that execution model. PHP is designed from the ground up to run, from scratch with opcache. We've seen that this morning, opcache and opcache preloading coming in PHP 7.4, and every optimization that was made and every optimization that is made in the frameworks like Laravel, like Symfony, with the compilation of the container and the caching, everything is made for that execution model. PHP has a head start, and PHP is a perfect language for serverless. Anyway, what about the pricing? The pricing is different too. You will pay only for the time your code is actually running. Not when the container is waiting for request, because it's just an optimization thing. You don't really have to care about that. You only pay for when your code is running, and that's the formula here. So for one request, obviously, it's not much. Just to give you an idea, if your code was running and processing, let's say your code is really fast, so it doesn't really, like 100 milliseconds per request, okay? And it's running for one whole month at 100 requests per second. So 100 requests per second on your application for one whole month continuously. You would pay for that around $20. That's just to give you an idea. So that's getting interesting here. But it's not just the pricing, because the cost of the execution time is obviously more expensive on Amazon Lambda than if you use any kind of server. Obviously, you have a higher level service. But still, it's interesting because we only pay for what we use. Let's have a look at this graph. Let's say it's the graph of an application running in production, like the traffic. Every hour, you have the sum of the number of requests. And you can see that during the night, there is not much traffic. You have a little spike in the morning, and then a big spike at the end of the day. And maybe your graph is different in production, that's fine. What's really interesting here is that when we are going to, if we don't do serverless, we are going to buy a server or rent a server or many servers to handle that specific spike here. So we're going to pay for a server that is designed perfectly at 9 p.m. At 9 p.m., we pay exactly what we should pay. Maybe we pay twice because we have some room, But anyway, perfect. But any other time of the day, we pay too much. So the idea with serverless is that you only pay for something that is proportional to the green area here. You don't pay for the large box, same amount every day, every second of the day. You only pay for what you use, which is like the green area. So this is a bit theoretical, but take your graph. The more blue you have in your graph, the more you are paying for resources you are not using. The more blue you have, the more you are wasting money, basically. And the more blue you have, the more you could save potentially by moving to serverless. Now, it's easily said. Sometimes, it depends. It gets really interesting when you have variable loads and you have a lot of blue. There are also some scenarios where you have a lot of blue, like workers or batch processes that are really important that we put on a whole web server and that run during the night just for 1 or 2 hours. For them, we pay a whole server during the whole day. There's a lot of blue, a lot of money to be saved. So to sum up about function as a service, again, just like serverless in general, the advantages, or the supposed advantages, because it's not always green, of course, it's that we have to manage less stuff. We don't deal with the physical servers. We don't have to manage the virtual machines or the containers. And when we use Lambda, we just select a language, and then it's up to Amazon to make sure that Linux, because those are Linux containers, Linux is up to date and is patched with the latest security versions, and that Amazon Lambda can scale correctly, and that you are, up to date on everything. You can scale more easily because of the execution model that we've seen, and because you scale at a very granular level. So it's really easy to scale, at least only when you consider Amazon Lambda. And you pay only for what you use. Now, I've mentioned Amazon Lambda, obviously, because they were the first to start in 2014, so it was quite some time ago. And they've been followed by the major cloud providers like Microsoft Azure Functions, Google Cloud Functions. We have IBM OpenWhisk. This one is interesting because it runs with Docker containers, real Docker containers. So you can easily put your application in there. In the rest, they use their own system, let's say their own Docker, their own container format. But in the end, I think that's interesting, this approach, because not having to maintain the containers is actually, less things to manage. So that's interesting. There are many more providers getting into this field, and I cannot list them all here. Now, okay, what about PHP? Because on Amazon Lambda, there is no support for PHP. That sucks. PHP is perfect for serverless. Why? Well, until November last year, there was clearly no support at all for PHP. But in November, they changed the system. They changed the way Lambda runs. And they opened Amazon Lambda to any kind of language. So now you can run whatever language you want, like Haskell and COBOL. There are actually a lot of interest in COBOL on Lambda, because you can take very old scripts running on very old machine and put them in the cloud. And that's really interesting for some people. But anyway, with PHP, we don't have an official runtime provided by Amazon, but we can build our own runtime, our own PHP runtime. And the way to do that is a bit like creating a Docker container, which means we have to download the PHP sources, and we have to use the image that is used by Amazon in production. It's open source. I mean, I don't know if it's open source, but you can use it, and you compile PHP for that specific Linux version. Then it's not a Docker image, but it's very similar. You can create a zip file and make it work. Now, you probably don't want to do that because it's just more work. And if you don't want to do that, that's good, because there is Bref. Bref is an open source framework that will provide the PHP runtime for you. And actually, Bref is more than just the runtime. Bref started about 2 years ago. It started with very specific and weird hacks, but now it's completely integrated with what's called the open runtime in the Lambda. And it provides the PHP runtime, but any kind of tool you would need to run serverless PHP applications. So that's what we are going to see. Bref is not just about the runtimes, it's also about choices. It's not just about code, it's also about choices. Because getting started with serverless, you get to wonder, should I use Amazon, Google, Microsoft? Should I use the serverless framework? Should I use SAM? Should I use Apex? There are so many technologies out there, it's really confusing. With Bref, I went with the safest choices, the most stable provider, which is Amazon Lambda. If you want to try something, use Amazon Lambda. It's a bit more complex than the rest on some specific stuff, but it's the most stable one, it's the one with the best performances. So thanks to Bref, you don't have to have too many choices, you can get started really easily. Bref is also about documentation, a lot of documentation. Again, serverless is brand new, and the idea here is to help you get started as easily as possible. So documentation takes quite some time, but it's really worth it in my opinion. And finally, Bref is a set of tools. So with, as I said, the PHP runtimes, but also some specific integrations with frameworks or specific tooling. So let's get into the details. There are 3 runtimes on Amazon Lambda with PHP, not just one. So I will show them to you. Those are the 3 runtimes. And I'll try to explain why it's interesting not just to have PHP. The PHP function is this. It's the same thing as what we can do with other languages. It's a function that takes an event and returns a response. So you can put that in an index.php or script.php and write a Lambda function in PHP. That's the most basic PHP support you can get on Lambda. And it's actually quite powerful, but I guess right now you're wondering, what do we do with that? Okay, let's not do anything with it yet. Because what's really interesting is HTTP and PHP FPM. Bref can run and runs PHP FPM for you, so that you can take your PHP application, your Symfony, Laravel, Slim, Zen Expressive, whatever you want, even WordPress if you want to, and you can run it on Lambda. Since it's PHP FPM, it's the same execution environment as you can get anywhere. Amazon Lambda has some differences. For example, most of the file system is read-only, which is really good for security reasons, for performances, and for many reasons. But there are some specific stuff to get your head around first, but the rest is pretty standard. Bref takes care of running PHP FPM for you and setting it up perfectly. And finally, there's a third runtime, which is the console. I really like this one. It's useful like 1% of the time, but then it's really useful. It lets you run basically the Symfony console or Laravel Artisan in a Lambda in production. So if you know Symfony, or if you use Laravel Artisan, you can run on your machine, a command like this. But you can't run that command in Lambda because you can't SSH into a Lambda. There is no SSH. When there's nothing running, there's no container running. You cannot SSH into anything. So the console layer, the console runtime is a good way to get around this. You have the Bref CLI command, where you just take everything you've written above and you just pass it to the Bref CLI command, and that will run your command in production. And that's a great way to initialize the database, load some data, and run doctrine migrations, or whatever you can do with the command line. So those are the three runtimes. The main one, obviously, is PHP FPM. It's the one to write web applications and APIs, and that's the one you probably want to use. Now, to deploy the application, Amazon isn't really the kind of dashboard where you can go and click, 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 click. Most of the time, you want to automate it. You want to use what's called infrastructure as code. So Bref has made a choice, which is to use SAM for deploying. SAM is an existing tool. Bref did not reinvent the wheel here. And SAM is the official tool by Amazon to deploy serverless applications. And the way you use it is that you write a YAML file where you configure what you want to deploy. So it's a bit, I'm not going to go into the details because at first it's a bit weird, but I have a whole documentation that explains it. If you want to dig into it, that's fine. What's really important here is that you create a function and you set a handler. And the handler is like index.php. It can be public/index.php. It can be anything. It's the entry point of your application. And it's basically the same thing as when configuring Apache or Nginx. When you want to deploy, you've written the YAML file and you use the SAM commands. So you obviously want to install composer dependencies with a production mode, and then you run 2 commands. So I don't know why they didn't make 1 command. They are working on it, but it should be 1 command. Anyway, you run the 2 commands, and that's it. Your application is deployed on Amazon. Now, let's talk a bit about performances, because I'm sure you have so many questions with the execution model and with the containers, startup, and everything. So yes, let's talk about that. What I did is measure the response time of applications that don't do anything. Like I have 3 Lambdas. The first one is a PHP function, so it's the function that takes an event. It doesn't do anything. It's useful for integrating PHP with Amazon services like Amazon S3, SQS event, message queues, and everything like this. Anyway, HTTP application is just echo hello world, right? So it should be running in 0 milliseconds. And the Symfony application is again a hello world in Symfony, and it should be also running in 0 millisecond ideally. So I deploy that, and I run a set of benchmark, and this is what I get. 13 milliseconds, 55, 56. This isn't that good. But this is the most common mistake we can make when we try Lambda for the first time. See, here, this is the size of the Lambda. And it turns out that by default, Amazon Lambda proposes, and it makes you use the smallest Lambda available. So this is the RAM here, and the more RAM you have, the more CPU power you have. This isn't much RAM. This isn't much CPU. It's a very, very slow CPU. So it's really cheap, but it's not really useful for HTTP applications. So let's fix that and try with bigger Lambdas. And now it gets more interesting. Actually, those numbers should be now like 1 millisecond and 2 or 3, because we released optimizations a month ago, and I didn't fix the slide. But anyway, to me, it's really good enough. It's like an overhead that we don't see in most PHP applications. And it's an overhead that exists in current applications. I did the same benchmark with the Symfony application and the HTTP application deployed on a DigitalOcean virtual machine, and I got the same results as here. So basically, to sum up, performance is good. But there is a but. And those are the cold starts. So you remember when a request comes in, if there's a container available, fine. The container picks up the request, processes it, and returns the response. But the first time, the container has to start. That means downloading the code onto the container, booting the container, and starting a lot of things. And yes, it takes time. Fortunately, Amazon, and that's why they re-implemented their own container system. They created what's called Firecracker, and they built that especially for performances when starting. So there is still a penalty when starting. Here you can see the penalty you get for each language. PHP is doing quite okay compared to the other languages, but you have to accept the fact that you could get 300 milliseconds of response time, or sometimes it's 200, but you can get that added to your response time. Now you have to wonder, is it worth it? Sometimes it is, sometimes it's not. If you build a real-time application, maybe it isn't worth it. But I guess for most PHP websites, it's okay. It's okay, especially because imagine you write a great PHP application. You deploy it on a server and it's really optimized, and it's like running in 100 milliseconds, and you're really proud of it. And then suddenly one day, there's a big traffic spike on the server. And this is really good for the business, and this is really good for everyone, but since there is a traffic spike, everything slows down. And you don't get 100 millisecond response times anymore. You get much, much slower response time, like 1 second or 2 seconds. So at the most important time, you get terrible performances. Here with the execution model of Lambda, the worst you can get is this. So sometimes it's worth wondering, if that's the worst I can get, is it worth it? And for some scenarios, it is. Now, I mentioned the CPU power compared to the size of the Lambda. Here you can see it. You can see that the smallest Lambda is really, really slow. It's like 6 seconds to run bench.php. Bench.php is the script that Ziv mentioned this morning. It's included in the PHP repository, and it's used to benchmark CPUs and CPU and performance improvements in PHP. My laptop, which is quite okay, is around the same as this. And I had a friend who has a very powerful laptop. He ran around 0.6 seconds. So they have pretty good processors, honestly, pretty good performances. The DigitalOcean virtual machines was around this Lambda. So pretty good performances. overall. Just don't use this one, especially since you will pay for 6 seconds, where here you pay for much, much less time. So yes, it's more expensive, but you pay for much less time. Now, everything is not all perfect in Amazon Lambda and the serverless world. So the idea is to show you what I call the maturity matrix. It's a comparison of different use cases and how mature the ecosystem is for that use case. The first use case is jobs and the cron and everything like batch processes. To me, this is one of the best use case for serverless because you don't care about the cold starts. You just want scalability. You want to pay exactly like for what you use. And if you have a huge message queue and you have a lot of messages to process, then you want to process them as fast as you can. So this is perfect for serverless, and I will show you afterwards some examples. There's just one thing to be wary about. It's that it's not as simple as I would like it to be. So green is, yeah, great, good, go ahead, no problem. Orange is like you can expect some more effort. It's definitely doable, but you can expect some more effort. Because right now there is no easy integration with Laravel queues or Symfony Messenger. That's something I want to work on, but if you want to do that, you have to write it yourself. It's definitely doable, but you have to write it yourself. Now, if you want to write APIs, that's a very good use case for Amazon Lambda. The only exception is if you want to write very real-time, like time-critical APIs, then you have the cold starts, not so great. But for the rest, it's really good. You have good performances once it's warm, and if you accept the cold start, it's good. It's very reliable, and it's really simple because that's the most basic use case. Pretty great. Now let's get a scenario a bit more complex, and I've separated from the APIs an API that uses MySQL or PostgreSQL. Unfortunately, there are not problems, but limitations with anything related to specifically MySQL and PostgreSQL. If you want to use these technologies on Amazon, with Lambda, specifically with Lambda, you have to expect some very bad performances. Bad performances only for cold starts. This is because of networking architectures and whatever. We can talk about the details, but you can get sometimes cold starts of 5 seconds, even sometimes 10 seconds. So for an API, this is definitely not okay, and most of the time that will not work. The good news is that Amazon is working on solving that. They announced in November last year that they will fix it this year. And 1 month ago, they tweeted that they have basically fixed it already. It's just not deployed in production. So hopefully in the next weeks, in the next month, it should be fixed. Once that's fixed, that's a really, really great change, because then we can use MySQL and be pretty happy. You have to configure MySQL, so it's not as simple as just deploying an API, but honestly, it's perfectly doable. It's just a few clicks. I'm writing the documentation right now, and I will publish it in the next days, so this will go green very soon. And then we have some, it's okay, but if you expect huge traffic spikes or huge loads, then you have to be careful about dealing with MySQL connections, basically just like with any PHP application. So you have to be careful if you expect huge traffic. Just don't go in there and think that everything will be working perfectly. There are some things to work out. Now, websites. Website is the same as API. It's even better here because most of the time cold starts are much more acceptable in websites. Like 300 milliseconds, it's really nothing on a website most of the time. And what's even better here is that if you set up a pingdom or anything that pings the website every 5 minutes, then you never have cold starts, basically. So that's a really simple workaround. It's not as simple as an API because you have to deploy the assets, so the JavaScript and the CSS. You have to create, for that you can use a CDN, or you can upload them to Amazon S3. If you've done this is really easy. If you haven't, well, you have to click around, or I'm working on documentation as well on this. I wish it was green, but it's not. It should be a couple of weeks before it's completely documented and simple again. And finally, websites with MySQL or PostgreSQL. It's the same as the API, except here, sometimes it can be acceptable to have like 5 seconds delay. Because let's say you have an application that isn't really critical, and what's usually done is that you have like a React frontend or a Vue.js frontend, which loads immediately because it's on Amazon S3 or a CDN. There is no cold start there. So the application runs perfectly well, and then when you submit a form or when you want to load some data, then okay, sometimes there will be 5 seconds delay, but again, you can use a ping DOM or you can do some workarounds, and honestly, it's doable. It works, and I will show you some examples. And finally, legacy applications, don't do it. Too much uncertainties, too much complexity, you're really going to have some trouble here. Now, I've talked about the theory. I want to show you some case studies. Those are real applications running in production with Bref on Amazon Lambda. When I say real application, the first one is really mostly a joke. It's a small website, but still it's useful to understand. That was the first time I discovered Amazon Lambda. I was building a website which is called returntrue.win, and it's basically a puzzle for PHP developers. So you get a piece of PHP code, which usually looks really weird, and you have to invoke it with the parameter to make it return true. If it returns true, then you win, you can move to the next step. So here, I want something that is greater than 1, lower than 1, but not 1. And those are actually like comparisons that are not strict, but this one is strict. So if I pass in a float instead of an integer, then it works. You have many levels like this. Go have fun and try to solve them. Anyway, when I will build this, obviously I have to run the PHP code. I have to run it on the server. And I don't want to run your code on my server, because you may be sending something completely weird which will break my server. So that's why at the time I worked to run the code in Amazon Lambda. So this website runs with 2 Lambdas. The first one is the website, which handles the form. You submit the form, great. Now I call the second Lambda, which will execute the PHP code. And if you crash the second Lambda, that's fine. The website will return an error and say that you've done something bad. You can try again. The website is fine. Everything is isolated. So I did that a year and a half ago, and I launched the website, and it got some attention. People liked it, and I got some traffic. So obviously it's not like Google traffic, but still I was really happy. And that's when I realized that I didn't have to do anything. So those are the 2 Lambdas. So I didn't have to do anything. The website was running, and I never have to worry about whether the CPU was overloaded, whether I was lacking some RAM, whether I needed a more powerful server. It was just running all alone. And that's what it's all about. That's for the whole month. I got like 600,000 executions of the Lambdas, and it just worked. But I was a bit worried about how much that would cost me. So at the end of the month, I got a bill of $3. I was happy. I was relieved as well. And I was a bit intrigued because for all that, I just paid $3. And it's been running since then, and it's cost me $0 since then. So I thought, hey, this is interesting. Maybe I can run some stuff on Amazon Lambda. At the same time, I was working on another project called triticeae. Triticeae is a SaaS where you can run continuous integration for coding standards. So basically, it runs, every time you push to GitHub, it will run PHP CS Fixer or PHP Code Sniffer, whichever you prefer, on your code and report some errors. And then the pull request can be marked as red or green. And at first, I did it with a simple Laravel application. I used Laravel queues, and I set up on DigitalOcean, and I had like 3 or 4 workers. And it was running fine. But as I started to have more builds, I so that the workers would sometimes be running in parallel. And if I had more than 3 builds at the same time, then the build would be waiting to be processed. And I had 2 choices: either let people wait for the build or add more servers. Instead, I moved everything to Amazon Lambda. And now, anytime I push, every job runs immediately. Because every time I push in the queue, there is no waiting for a free worker. The free worker gets created immediately. And most jobs are processed in less than 5 seconds. So I push to GitHub, and I opened the page for the new pull request, and it's already green before I even saw it running. This is something that I usually see now, like triticeae has finished running, and the rest is not even running. It's just pending, waiting for a free container to run. And that really pains me to have to wait just for a free container on Travis or on Jenkins or on GitLab. So as a developer, extremely happy with all of that. I don't have to deal with scaling, with whether things are waiting or not, it just runs. As a user, and for users, this is perfect, because everything runs immediately, and there is no queue anymore, basically. You have a job queue, but it's not a queue anymore. Pretty interesting. I also have predictable costs, because I know how long build takes, so I can do the multiplication and know how much it will cost me for a certain number of repositories. Now there's uptier, which is a different company. It's a French company, actually. And this is a French startup in Lyon. What they do is they process a lot of energy bills, a lot of PDFs, and they extract information. So they don't have that much traffic on the website, but they do have a lot of jobs, background jobs. And they started with PHP, running as a worker on Amazon EC2. And it was running fine, but the startup was growing. And this is like last summer, they got more and more clients, pretty great, more and more jobs to run, and they started having scaling issues. They started having trouble adding new servers and keeping up with the clients and dealing with all the errors, and they started having a pretty huge Amazon bill. So they started to look into Amazon Lambda, and I said to him, hey, give it a try. So what they started to do in July is they started moving from EC2 to Amazon Lambda. And this is their Amazon bill. So it was growing continuously month after month, and when they started migrating to Amazon Lambda, it started decreasing again. It's been close to a year, and they've now migrated almost everything to Amazon Lambda. They haven't reached the level of July last year. So they saved a lot of money. I can't give you total numbers, but I can give you an example of a specific microservice that they moved entirely from EC2 to Amazon Lambda, and they went from $800 per month to $90 per month. For them, it was quite a success. They saved money, but as a startup, it's really interesting for them because they were not afraid of growing anymore. They had a huge client ready to sign. They were not afraid. They had less errors, less time spent maintaining everything, and it just runs. So for them, pretty interesting deal. Now finally, the last one is a website. And it's called SuaMusica. I don't know if I pronounce it correctly. I have nothing to do with that website. This is a Bref user who shared it on the GitHub repository. It's a Brazilian website about music and everything, and it runs with Bref. It runs with PHP on Amazon Lambda, and they are starting to migrate to Bref. Yeah, sorry about the confusion. They run with PHP on Amazon Lambda, and they want to use Bref because they don't want to maintain PHP by themselves. So, PHP and Amazon Lambda, they have the website, and they have the API, and they have pretty good response times. So for them, it works. It works fine. They use Falcon, and interestingly, they use MySQL. So they are in the the red or orange thing that I showed earlier, but for them it works really fine. I asked the person, how do you do with the VPC cold starts and the 5 seconds and everything, and he just answered that he doesn't notice them. Maybe the website is always warm, or Amazon is also pushing a lot of optimizations to reuse IP addresses and network stuff. So in the end, for them, this is not an issue. Because their website is actually a very big website. They processed 40 million requests per day. And I looked it up yesterday, they're in the Alexa's top 3,000 websites. To give you an idea, Laravel.com is the same range. PHP.net is top 2,000. So they do have a lot of traffic. They do use MySQL. They do use PHP on Amazon Lambda, and for them, it runs really great. At peak time, they have like 2,500 concurrent Lambdas running in parallel. So they have 2,500 containers of some sort. But they don't manage it. And what's really interesting behind that story is that they first started with running everything in containers on Amazon ECS. And when they migrated to Lambda, they saved 25% in terms of Amazon bill. They did spend some time to migrate, but they are also really happy because now they have less things to manage. They don't have to scale the servers or the containers anymore. So for them, it's a win, both in terms of money, but in terms of effort and time. I'm getting close to the end. Usually, a feedback I get is that I don't show a demo. People would like to see a demo, so I'm going to try that. And it's really risky. Okay, don't worry. Okay. Will it work? I shut down the Wi-Fi. It's connecting, okay. Okay, this is a demo of Bref running in production on Amazon Lambda. This is a website. It's just running, it's just a usual website. There's nothing to show to you because it's just a matter of infrastructure. That's what I want to get across with this demo. There is nothing to show. Yes? Yes, we'll talk about that in the questions. I'm going just to finish. Yeah, I think I can close that and get back here. Okay. So before answering questions, just to conclude, what should we take away of all of this? Should we move everything to serverless? I don't know, but I do think that where we are going is towards serverless. We are moving towards the cloud. I think that's pretty safe to say now because the cloud is pretty much everywhere in our jobs. But doing less and less and less is definitely the trend we are seeing. And using more and more services, function as a service is just one of them. But using more and more services for everything, like Amazon S3, Amazon RDS, or whatever it is. It could be Algolia for search. It could be Auth0 for authentication. There are so many services. This is where we are going. Now, should we jump aboard? Is serverless even mature to move all our applications right now? I think the question is not really clear. The answer is not really clear. Serverless technologies are mature. Like if you use Amazon Lambda, it's used by very, very big companies and a lot of companies, and it's been running in production since years, and this is working. But obviously, our PHP applications, our PHP frameworks, and us as a community, we don't have the same maturity and the same confidence and the same expertise on all of these topics. So not really. It's not as easy as just moving everything to serverless. But I think it's worth going that way. So what we should do is try, is learn and share what we've learned. That's what I'm trying to do today. I'm doing that because I think there's a lot of potential here. And hopefully, you can try and make your opinion for yourself. If you want to try, there's Bref, bref.sh. If you want to keep up to date with anything that's happening in serverless related to PHP, there's a newsletter that I created as well, and you can ask me any question now or on Twitter. I'd be really happy to answer them. Thank you. And regarding the DDoS attacks, yes, it's a possibility. Just like I can DDoS your application and it will go down. Here you can either choose to keep your application up but pay a lot, or you can set up restrictions, like limit the number of concurrency, or set up the Amazon firewall, which will block all DDoS attempts. All, I don't know, but some DDoS attempts.